In today's video we're fault finding a high current joint. So my DC to DC charger is cutting out throughout a current overload. So I'm trying to find out where the current overload is happening. To help find this fault, we're using the Bosch GTC 400C. It's a thermal imaging camera. Now, even if you buy just a cheap thermal imaging camera, it's perfectly fine, because all you want to see is where the hot spots are. It's not like you're trying to use this for a circuit board diagnostic. If we have a look what the temperatures are, the DC to DC charger is running at 22 degrees. Ignore how white it is, because it's just in comparison to the surrounding area. This is another trip switch which is running at 60 degrees. And if we come down to the trip switch down here, this one is running at 44 degrees. So I think my thermal current load is actually coming from these connectors as they're getting too hot. What I think I need to do is actually change these two fuses, and then we won't have such a build up of heat. This shows the service point on the Ford Transit. The top wire goes to my leisure battery and the bottom wire is going to my DC to DC charger coming from the alternator of the vehicle. If we now bring in the thermal camera, we can see that the bottom cable is warmer than the top cable, and where it goes through the wall joining onto the other side, we're at 9 degrees, and then the rest of the cable gets cooler as it goes down. So my fault is not at this end. I think that 9 degrees coming there is actually coming from the join on the other side. The DC to DC charger is noticing that there's a voltage problem and keeps dropping the voltage down to stop these from overheating. If we turn the panel on, hopefully this will show up. It's going between 6 amps of charge and going up to about 25 amps of charge and varying. So if we turn the camera back on again, we're now at 70 degrees in the center of this unit and 50 degrees on the ends, which is transferring across. So it's not actually my joins, it's this unit is actually not powerful enough. Even though it's a 40 amp fuse, it's acting as a heat sink. But this one is definitely a 40 unit. So what I'm going to do is order up a couple more fuses for this and try those and see whether it works better. What we've done is I've taken out the fuse that used to be there and I've put in a mini fuse connector down here. So now I'm still running with fuse protection from the main battery, but I'm not running on the adjustable fuses anymore. And now we seem to be steady with the amount of ampage that we're putting in. So we've got 25 amps going in here now, which seems to be quite steady. This is another reason to have an open cupboard like this, so that you can get to all the individual wires, so that you can quickly do fault finding and adjust any problems that might occur. So now on the thermal camera we're showing 15 degrees on the junction, whereas before we were at 60 degrees. And then the cable coming up is showing perfect now, not showing any heat build up at all. Now the DC to DC charger at the back of it is at 30 degrees now, and I've had the battery charger on, the blue smart charger, and that's sitting at 24 degrees at the top. It's turned off at the moment. Having a thermal camera definitely helps when you're fault finding a high current spot. Without this thermal camera, it would have been a case of just feeling the joints with your fingers and deducing which ones were warm. Thank you for watching and subscribing. I'll leave a link in the description below where I got this thermal camera from on Amazon, but as I say, you can quite easily use any of the cheaper ones because you don't really need the resolution, you just need to know what's hot and what's not.